This is June 19, paper 4. A nucleus emits a nucleus of nucleus is there, emits a beta particle. The nuclear physics is actually like before it was some part was there in unit 4 and some in unit 5. But now all nuclear physics is in unit 5, like the emissions, alpha, beta, and gamma and their effects. So this is because according to the old one, so in a beta, this is a negative beta decay. In a negative beta decay, what will happen? The nucleon number does not change, but the proton number increases by 1. So if element X is there, 69 and 30, if it is beta, it will remain 69, but proton number increases by 1. If the proton number increases by 1, the nucleus will change, and this will be beta, 0 and -1. So what will happen to a proton number? Proton number becomes 31. But what will happen to nucleon number? No change. So C will be the right answer for this. Why proton number increases by 1? Because in a beta decay, there are two types of beta, negative and a positive beta decay. In a negative beta decay, a neutron will break down into proton, electron, and anti-electron neutrino. So as one of the neutron breakdown, neutron number decreases by 1 and the proton number increases by 1 in a negative beta decay. But in a positive beta decay, a proton will break down into neutron, electron, and anti-electron neutrino. So in a positive beta decay, the neutron number increases by 1 and the proton number decreases by 1. So this is what happened. Yeah, both positive and negative beta decays are part of the syllabus and in detail we'll discuss in nuclear physics. Unit 5 topic rather than unit 4. As I mentioned, this topic is now moved to unit 5 before it was in unit 4. A DVD is rotating at a speed of 270 rotation per minute. So, 570 rotation per minute. So if we want to convert this rotation into radian, 570 into 2 pi per minute, 1 minute, how many seconds are there? 60. So 570 into 2 pi divided by 60. 59.6 or 60 will be the answer. Shows a simple electric motor, the current of a 0.1 ampere, 0.4 ampere, with a magnetic field of 0.07, the length of XY, like this section, length of XY is 5 centimeters, 0.05 meter. And it is perpendicular 90 degree to the magnetic field. This is 90 degree to the magnetic field. So how we'll work out the force? F is equals to BIL. The force on a wire in a magnetic field is BIL, where B is the strength of a magnetic field, 0.07, I is the current that is passing 0.4, and L is the length of the wire which is in a magnetic field, so 0.05. So 0.07 times 0.4 times 0.05. So either A can be an answer or B. Because we need only the force on side XY. Now how to know whether a force is, what is the direction of the force? If you want to work out the direction of the force, so then in that case, you have to use Fleming's left-hand rule. Your index finger will point in the direction of a magnetic field. Your index finger will point towards south, the direction of a magnetic field. Your second finger represents the direction of a current, which is from X to Y. So your second finger will point towards you or out over the screen. Where the thumb is pointing when you apply the left-hand rule. So index finger is pointing south, second represent direction of the current, thumb is pointing the direction of the force. So the thumb is pointing upward. So as the thumb is pointing upward, so what is the direction of the force? The direction of the force will be upward. And this side that the force will be, because the current is opposite, so the direction of force will be opposite. So it will be downward. Whenever we want to find the force on a wire in a magnetic field, we use a Fleming's left hand rule. But whenever we need the direction of the induced current, we use the right hand rule. Like if we want to find which direction the current produced due to a motion of a wire, right hand. If you want to find the force on the wire in a magnetic field or a current carrying conductor, you will always use the Fleming's left hand rule. Kaon can decay in several ways. Which of the following decay is not possible? First thing, if you want to check a decay is possible or no, check the charge conservation. Is the charge conserved? So here is 0, +1, -1. So here the charge is conserved. So this can be possible. Like in terms of the charge. This is 0, +1, +1, and 0. So this is not possible in terms of the charge. This is +1, 0, +1, 0. So this is also possible. +1. The conservation of the charge. So according to conservation of charge, A, C, and D are possible. Next conservation. You can check the conservation of a lepton number, or you can also check the conservation of a baryon number. It's up to you. Any one of the conservation you can check. Let's say the conservation of a lepton number, if we see lepton number for every lepton, the lepton number is +1, and for every anti-lepton, the lepton number is -1. Kaon. Kaon is not a lepton. So what is the lepton number? 0. Pion. Pion is not a lepton, it's a meson, so lepton number is 0. Then electron. Electron is a lepton. Its lepton number is +1. And anti-electron neutrino is a lepton, like anti-lepton is -1. So lepton number is conserved. So this is possible. Yeah, that's I'm saying. Yeah, the correct answer is B, which is not possible. I already worked out, but I just want to show that you can also check with other numbers as well. So B is not possible. That's true. That I already mentioned it is not possible. But the thing is, you can also check with other variable. Like you can either check with the baryon number, lepton number, but first you start with a charge. This is 0, this is 0, this is 0. This is 0 as well because they are or not. So here what I'm saying is you can see lepton number is conserved. Lepton number is conserved, but the charge is not conserved. So means it's not like even one of them is not fulfilling, then you will say it is not possible. Is it clear? So first always start with the charge, then start with a lepton number and then the baryon number. 2-point charges, each of a charge Q are separated by distance R. 2-point charges, each of a charge 2Q is separated by distance 2R. What is the force? The force is directly proportional to product of the charge and it is inversely proportional to square of the distance between them. So first, when the charge was Q, the product was Q square. Now that when the charge is 2Q for each of them, the product is 4Q square. So the force will increase by factor 4. And it is inversely proportional to R square If a distance is double, what will happen? It will decrease by 4. So due to the charge, the force is multiplied by 4, and due to the increase in the distance, it is decreases by 4. So one is causing an increase by 4, another one is causing a decrease by 4. So they both cancel out the effect of each other. As a result, what will happen? We'll have C as a right answer. A linear particle accelerator or a LINIAC. The diagram shows the drift tubes at the start of a linear accelerator. At the end of a linear accelerator, drift tubes are same length. Which of the following is a reason for that? The frequency of accelerating potential difference is increasing. Look, the frequency, we don't change the accelerating frequency. Like, what is the meaning of the term accelerating frequency? Like how much time it will take to change the poles. First this positive, negative, positive, negative, positive, negative, positive, negative, then negative, positive, negative, positive. So we apply the same potential, same frequency. It is not changing at all. The particle has no longer gain energy. It will gain energy, but what will happen? The particle will have a sufficient speed, and when the particle will move close to speed of a light, what will happen? Its mass increases. So as its mass increases, it does not have the same change in the speed. So the particle will no longer gain energy. It will gain energy, but the gain in energy will be affecting its mass. But this is a condition. Look, the frequency part, when we use an accelerating potential here in a linear particle accelerator, so we use a constant AC supply, which is, let's say, a constant AC supply, which has a frequency of 50 hertz. So 50 hertz means 1 divided by 50, the time period. So 0.02. So means after every 0.02 second, the terminal will change. For this positive negative, after 0.02 second, this will be negative positive. Then after another 0.02 second, negative positive. So these terminal changes, they changes with a constant rate. So that's why the frequency of accelerating potential increasing, we don't increase at all. The frequency of accelerating potential is always constant, does not change. No, it's not about the time the particle take in the tube. It's the particle speed, like the length of the tube at the end is not changing. We keep it same. So why the length of a tube we kept it same? So it means it should take a same time. So it means the speed of the particle is not changing. Yeah, that is what we are saying. What is the reason for that? Because when the particles are accelerated, let's say it took for the first, every tube, it will take the same time. Let's say it took 2 seconds to move here. It will also take 2 seconds to move here. It will also take 2 seconds to move here. It will also take 2 seconds to move here, 2 seconds to move here, and same 2 seconds to move here. So all the tubes, the particle will take the same time to accelerate, move. What is the difference here? The speeds are different. Here, if we compare the speed, V1, V2, V3, V4, but then the tubes are same length. So it means V4, V5, and V6 are the same speeds. Because if the speed of the particle is same, then what will happen? It will take the same time to move in each tube. So what actually happened? The particle has no longer gain energy. That is also wrong. The particle will gain energy, but that energy which it will gain, it will increase the mass. E is equals to mc square. So the energy which the particle will gain, it will increases the mass. The rest mass of a particle increase. Rest mass does not change. Rest mass is the mass of a particle which is when it is at rest. It should be the mass of the particle increases. If this was a statement given to us, then we'll select C as the right answer. So when the particle move between the tubes, the mass of the particle increases. As a result, the mass of a particle increase. The particle move with the same speed even we supply energy, because E is kinetic energy, Ek is equals to half mv square. So the speed is not increasing, the mass is increasing. As the mass of particle increase, it will have the same kinetic, like the kinetic energy will increase, but the increase in kinetic energy is not increase in the speed, it is due to the increase in the mass. So when the tubes have the same length, it means the particle speed is not changing. The speed of the particle is no longer increasing. If the speed of the particle was increasing, then we have to make these tubes longer so that the particle will take the same time to move through these tubes. Rest mass is the mass of a particle when it is at rest. So rest mass of electron is 9.1 into 10 to the power minus 131 kilogram. But when the electron moves close to the speed of a light, then the mass of electron will be more than this value. We don't say it's a rest mass, we say the mass of particle. Rest mass is a constant thing. The mass of a particle can increase, but the rest mass is the mass of a particle when it is stationary or at rest. So because the particle is moving at the same speed, that's why. And why it is moving at the same speed, even though it is gaining energy? Because the energy which it gains, it increases the mass of the particle, not the rest mass. How we know that we should stop increasing the speed? No, we are not stopping increasing the speed. The particle does not accelerate in terms of the speed. So that's why the tube at the end are kept at the same length. Because here the particle was accelerating, here particle also accelerate, here also particle accelerate. But the energy which is provided to the particle, the kinetic energy, instead of increasing the speed, increases the mass. So when it increases the mass and the speed does not change, so the next tube should have the same length of this tube. Then when two vectors are perpendicular, we want to find the magnitude. So just use the Pythagoras theorem. So it will be a 35 square plus 25 square in a root. So D will be the right answer. Because the Pythagoras theorem result in perpendicular vectors are there. Then if we need the angle, what is the direction of the resultant? This is 35 and here is 23. So resultant is from tail of the first to the head of the last. That will be the resultant. But the angles, they give us angle from the vertical. Like all the discussion, they give the angle from the vertical. Or we can also say from bearing. Sorry. So if we need, this is our angle, so this will be 23 and this will be 35. So according to that, this is the hypotenuse, here is a perpendicular and this is a base. So tangent theta is perpendicular divided by base. So theta is equals to tan inverse 35 divided by 23. So in that case, B will be the right answer. Because the angle with the vertical they showed in the question, these are totally wrong because the direction of the vector which is drawn is incorrect, the resultant. A beam of high energy electron is directed at a simple crystal material. As you can see, just we discussed in the last paper as well, the electron diffraction. that when these electrons are passing through the crystal, they tend to show the pattern same as like a pattern of a diffraction of the wave. So this can be observed to set a concentric circles in a fluorescent screen, which is a diffraction pattern. Which of the following change would decrease the diameter of the circle? Like these circles you can see, this is the diameter of the circle. So we have the formula lambda is equals to h over mb. Like the wavelength which is associated with this electron is inversely proportional to the momentum. If we want the diffraction, if we want a less diffraction, as we know, when we have a longer wavelength diffract more. But we want to decrease the diameter of the circle, or we want a less diffraction. So use a crystal with a smaller spacing. So if I use a crystal with because longer wavelength diffract more and small gap size. When the gap is small, so if I use a smaller spacing, like let's say this was the first crystal we use, then we use a smaller crystal. So if we use a smaller crystal, it will diffract more as compared to this one. It will diffract less. So this will cause a more diffraction. If it causes more diffraction, then the diameter of the circle or the diffraction, this you can say the spacing between these circles will increase, or the diameters of these circles will increase. But we want to decrease. So it cannot be A, use screen further from the crystal. So as we move further from the crystal, what will happen? That will also increase the diameter. Like if I have, let's say this was a crystal and I put a screen here and the wave is diffracted, wave is collected on this one. But if I put a screen far, so as a result, what will happen? The concentric circles will have greater size, like because I'm taking an image far from the object. So this will also increase the size. Electron with a greater momentum, if I use an electron with a greater momentum, it will shorter the wavelength, and shorter wavelength diffract less. And use an electron with a low speed, if I use an electron with a low speed, it will have a longer wavelength, and longer wavelength diffract more. Is it clear, this one? A ball of a mass 0.4 kilogram has a kinetic energy of 9. Which of the following? So the formula which relate the momentum and the kinetic energy and the mass, Ek is equals to P square over 2m. So if you need the momentum, it will be 2m into Ek with the root will give us P. So it will be 2 multiplied by mass 0.4, kinetic energy 9 in a root, that will give us the momentum. So 9 into 0.4 into 2 in a root, that will give us momentum. So C will be the right answer.